cluster with the help of Docker Swarm, right? Docker Swarm. With the help of Docker Swarm, there we created. Oh, sorry. So there actually, what we have seen with the help of Docker Swarm, we have created the cluster, right? With the help of Docker Swarm, we have created the cluster. Okay, so in cluster, what we have seen, in cluster there is one master node, right? There is one master node and one worker node and a second worker node. Okay, so now one more question I have, like, previously we have only one master node and two worker node. Okay, so now I want two master node here. Okay, so here I want two master node and I want to increase one more worker node. Okay, there is only worker node 1, worker node 2. So now one extra like worker node 3 I want. Okay, so in this situation, how you can increase means assign one more master node? Anyone having idea? And I want to increase one more this one. Okay, worker node. So there is only one simple command. Okay, there is one simple command. This one. Actually, in the previous classes, I already shown you guys like how we can check the token, whatever the token is generated while creating the Docker Swarm means cluster, right? So when we have created the cluster, okay, see here we have created the cluster, right? Docker node. Oh, so Docker node ls. So here we have created the cluster with one master node and two worker node. Okay, so now one command I have given, okay, to check if I want to see what's the token of master node. Okay, with the see in a starting we have initialized the Docker Swarm. Okay, at that time one token is generated. Okay, one token was generated. I want to see that token. So what is the command? So what is the command, guys? Anyone remember? This is the command. See, when you have initialized the Docker Swarm, that time one token is generated. Okay, if you want to check it again, okay. So if you will execute this command, Docker Swarm join token manager. Okay, join token manager. So here what you will see, whatever the token will be available on the master node, that will show. Okay, see, this is the token. Okay, so this is the token. Here you can see, to add a manager to this swarm, run the following command. Okay, if you want to add one more master node, okay, then you have to execute this join on any server. Okay, any server that you want to make as a master. Similarly, for worker, if you will write here in place of manager worker, okay, in place of manager, if you will type here worker, you can see one more token here. Okay, so these both, one, this token is for master. Okay, this token is for master, not same. Okay, this is little bit different. See, in a starting maybe same. Okay, if you will see in a starting, I think till this one, right? Till till this one is same, okay. Till this one is same. Master and worker having same, but from here different, okay. So like if you want to more, if you want to create one more master node, then you have to execute this join command on any server, okay. That will become as a master, okay. So okay, so that will become as a master, okay. If you want to increase the number of worker node, you have to execute this command, means this token, okay. So I think this is clear to all. If you have means try these things, okay, try these things, apply these things, okay. Like see, right now I have three server. So right now I haven't created one more server, so I can't show you this. Okay, later on I will show you this. This is simply okay. So how we applied this token on one server that become as a worker node. That's only okay.
So basically, we'll create a one machine and just run the command. If we want to
Yes,
make a
yes.
master, then we'll run the top command, and if you want to make a worker, then we'll make run the below one, right?
Yes, yes, correct, correct.
Okay.
So see, generally, means interviewer will ask you why there is a need of two master node and multiple worker node. Then what you guys will reply? Hmm? Then what will be the answer? If some,
If might be one,
if
if might be one master node will be crashed, then second master node will work at that time because of
yes,
backup wanted to be create, right?
yeah, yeah, exactly, exactly. Good. So I think this master concept, I think, and worker node concept is clear. I think this is clear to all. Guys, clear, right?
No, it is.
Okay, okay. So yeah. So now we will come to the Kubernetes. Okay. So now today we will start give a start of Kubernetes. Okay. So
So
see
so
whoever
n number of backups we will create, or it is the limitation like two or three backups we can
no
create.
in number you can give in number.
And
There
number
is no any
master as well
limitation.
as workers, right?
Yeah, yeah, yeah. See and
Okay.
see that is depend on your cluster. Okay, how big is your cluster? Okay, that
Hmm.
depends on your cluster. Like see, a simple example I am taking. Like see, in a company, in an organization, like we have a small like team, some big team. Okay, so big team, if like see in your team like eight members are there, okay. So in eight member, if there is only one manager and one team lead, so that can be handled, okay. See if your
Okay.
team is like big, like if 35 30 means 30 to 40 member in the team, okay. So there is the requirement of like two manager or maybe
Okay.
three manager is required to handle those all engineers, right.
Okay. Yes. Yes. Correct.
So in
Correct.
that
Yeah.
similar kind of situation is available here. Okay. According to your cluster, you
Hmm.
can create two master, three master. Okay. So if I will talk about my cluster, means wherever I'm working, there I have three master node. Okay,
Okay.
three master
Yeah.
node, and
Yeah.
more than like 90 worker node. Okay. So
Okay.
yeah. So we
Okay.
will
Yeah.
see.
Got it.
Uh, okay. So yeah. So now we are coming to the Kubernetes. So, yeah, Kubernetes. Okay. Hello. Nandita, you missed one things. Can anyone explain the same things to Nandita? Actually, she joined now. So, same things. Can anyone explain? I'm giving you the giving the pictures here. Guys, anyone can explain this so that Nandita can get these things, because this is the uh, point that we missed yesterday. Then after we will start Kubernetes. Okay, someone please explain this. Okay,
Yeah, yeah, yeah.
this.
Sure, sure. I'll explain. Yeah. Okay. Okay. This is all about to add the worker node or the manager node. Sorry, manager, right?
Yes, yes.
Master. Sorry, master node and
Master or
worker
manager
node
both you
extra.
can. Mhm.
Okay. So this is all about if we want to we add more master node and worker node based on our requirement. So so this is the first command. The command it is where it is. So this is the picture image it is. If you want to add more master node or the more worker node. So there is a command it was run. Can you show the command?
Yeah.
Yeah, it is a top command. So once we'll run the the Docker swarm join token manager. So in this, once we run the this command, we will get the below one to add the manager to this swarm. So we'll create one machine, and if we want to make that machine as a manager, then we'll run the top one command. If we want to that machine as a worker, then we'll run as a drop below one command. So this is all about.
Yeah. So, Nandita, here actually what happened now? Yesterday, actually, I missed one thing. Okay. So, yeah. So actually, see previously what we have seen now, there is only one master node, and there is only one. There is two worker node one and worker node two. See, if requirement in your organizations like two master node is the requirement, okay, and there is requirement of three worker node, okay. So additional means one master node and one worker node is required, okay. So in that situation what you will do, previously you have already one cluster with two worker node one master node, okay. So now what you will do, by executing this command, here if you will see, docker swarm join token manager is here, okay. So here one token you will be able to see, okay. And if you will execute same command with worker, one more token will, you will see both tokens are different, okay. If you will see till this one will be similar, okay. After that these both are different, okay. So if you want to add one more master node, then you have to execute this command on your server which you want to make as a master, okay. And the server which you want to make as a worker node, that you have to execute this command, okay. That's only. So I think clear
Okay,
to Nandita.
same like a cluster, like same like a cluster. Here only we are adding two master.
Yeah, yeah, yeah. So additional we are means there is like requirement like one more master node that we did only. Okay, so you guys had to apply this one. Okay, so right now I don't have one more server, so I'm not able to show you. So later on I will show you this one also. Before this one, today we will start basic of Kubernetes at least. Okay, today I will take like 20 to 30 minutes only. Uh, okay. So yeah, so now
Uh,
yeah.
in the organizations, like already it has been created, this master node, or already it has been
So,
created.
sorry, surprise normalization. What you do?
Yeah, I think what I'm asking is in organizations already this has been created, right? This master node, if the
Yeah, yeah,
requirement also in those scenario we need to depend upon the requirement we need to do it, but usually it already existed, right? It's already will be there.
yeah. See, in organizations, what will happen? See, in a starting, like in your organization, only two master node is available. Okay, so
Yes,
like
yes.
now workload is increased. Okay, now workload is increased, so there is a requirement of one more master node. Okay, so in that condition, like one more master node, four more worker node, in that situation we can add it. Okay,
Okay. Thank you.
yeah, so that's all. Okay, so see, whoever like means uh, have seen these all the things in Docker, so that will be definitely means will be more benefits to learn Kubernetes. Okay, if you knows about the Dockers, like in Dockers we learn so many things like how we have created the container, like networking. We have learned so many things. Okay, so many things we have learned in Docker. Okay, so basic Kubernetes means basic of Kubernetes means basic of Docker you should know. Okay, basic of Docker you should know. But in Docker also we have studied it a lot. Okay, everything we have seen. Okay, so almost I have covered whatever the topics required in Docker that I explained in the class. Okay, so that much is I think means okay. So yeah, so now comes
Like
to
you
the
have covered all the topics. Most of the topics you have covered.
yeah means yeah I think means from my side all the topics I try to cover it. If some topics like I missed, then you guys let me know. Okay,
No,
is
I
someone
think
having
we
like
have covered all the topics.
all the topics, right?
Yeah, right.
Yeah, okay. Yeah. Okay, so now we will explore this one Kubernetes. Okay, give me a second. Okay, so guys, yeah. So one and two. See, there we learn container. Okay, in Docker we learned about the container. Okay, now here we learn about the pod. Okay, we will learn the pod, and here will be the container. Okay, so see, in Docker, what we have learned in container, your application jar is available, right? Right. See, log DevOps, log DevOps jar is available, and with the help of that jar, you are able to execute your application, right? Execute your applications. Okay, but in Kubernetes, okay, in Kubernetes, directly we do not have container. Okay, you have pod, and inside the pod there will be container. Okay, we will see these things deeply. Okay, these things we will understand deeply. Okay, and see in Docker, like we have seen like replica and a scaling, a scale up and a scale down, right? So there we what we did there we have scaled a container. Okay, there we have scaled container, and here what we will do? Here we will scale this one pod. Okay, here we will scale pod. So whenever we will talk about the pod, okay, so this pod will comes under the cluster only. Okay, this will come under the cluster. Okay, so now you guys tell me in Docker which cluster you how we create the cluster in Docker, how you create the cluster
Using Docker Swarm.
So
using the Docker swarm, right? using the Docker Swarm. Okay, so here here also we will create cluster. Okay, cluster. Here what's the option is available? Here two option is available. Okay, here two option will be available. Okay, so one is QADM. Okay, if you will create in Kubernetes two method we have. Two method we have to create cluster. Okay, first method QADM. Okay, QADM, and second method is minikube. Okay, minikube. See, when we will use QADM, QADM means you want to make in a node. Okay, in a node. In a node means like if there is requirement of like 30 cluster node. Okay, 30 cluster node. Like some organization require 90 node. Okay, in this situation you can use QADM. Okay, and minikube, when we will use minikube, only we will use in single node cluster. Okay, single node cluster. Minikube we will use in single node cluster. Okay, this we will use in single node cluster. Okay, so now when this QADM is required, when we will use QADM, and when we will use this one. See, in organization, like if you want to go like on production level, okay, if you want to go on production level, okay, so on production level, what on production level there will be like more than one master node and two worker node. Okay, like 30, like 20, like 10, means more than 3. Okay, in that situation we will use QADM. Okay, in production types of projects required like more worker node, means more node. Okay, right now we will talk about the node. Okay, so I think word node is clear to all. Anyone have doubt about node? Means anyone is available here who don't know about node, means what is node? Clear to all? Node is,
Node means machine, right? Virtual machine.
yes. Node means you can tell, you can say like virtual machine. You can say like instance. Okay, you can say like server. Okay, I think node is clear to all.
Yes.
See, in Kubernetes, we have given the command docker node ls. Okay, so here we have three node. This is the master node and these two are the worker node. Okay, so I think this is clear to all. Okay. Node is clear. Okay. Now see, in single node, when we will create the minikube actually Kubernetes have given one like minikube cluster, because see, we are the student, right? here we are the students who wants to learn the Kubernetes. Okay, so a student do not have much server availability. Okay, like a student having like 3 4 server only can create. Okay, in these situations we can learn the Kubernetes also. Okay, so there in single means mini cube when we will create, like there is a requirement of one master node and two worker node. Okay, worker node 1 and worker node 2. Okay, in that situation you can use mini cube. Mini cube generally we are using for the study purpose only. Okay, and cube ADM generally we are using for the production level. Okay, so I think the word cube ADM and mini cube is clear to all. Okay, see, cube ADM and mini cube. See, actually, if you will talk about the Kubernetes is nothing, but this one is also called K8 cluster also. Okay, I think some guys maybe listen about this word K8 cluster. Okay, so we will explore means Kubernetes means if someone will ask what is Kubernetes. So you can say like Kubernetes is like a orchestration tool. Okay, now you will ask what is orchestration. Okay, so what is orchestration? Hmm? If someone will ask you what is orchestration in Docker, I think this word I explained. Someone remember?
Yes, it is a huge infrastructure or a system, you can say like that, which is responsible to keep all the resources and requirement for the running.
Yes, exactly. Good answer. See, orchestration means, see here what we have seen in Docker, what we have seen exactly. There we have one master node and worker node. Okay, so there what happened actually, whatever we have created the container, okay, on master node, okay, that are distributed on worker node as well, right? So that is the means orchestration. Orchestration means distributed work. Okay, means one person will not do one work. Okay, see it's like in company, like one work is assigned. Okay, so like if one worker is assigned, someone will tell you, like manager will tell you, okay, this work is assigned to you. Okay, and maybe your team lead will assign that particular work. Okay, similar kind of work here also. Okay, here in Kubernetes, why we are calling orchestration tool, because here is also the same things. Okay, here we will learn um, who is giving the work. Okay, where our pod will create, on which worker, I mean, so on which worker node our pod will create. Okay, there is one uh, in architecture we will see means who is giving the order, means where our code will create. Okay, that's why we are calling as a orchestration tool. Orchestration tools means we are talking about the here we are talking about the pod. Okay, so pod, here we are talking about the pod. Okay, so pod exactly what is pod actually? Okay, this is the smallest unit we are calling. Okay, a smallest unit, or you can say like object, or a smallest object. Object is what? Object is also we are calling like a smallest unit, right? Hmm? If
Yeah, in your languages, we have programming language object is smallest unit.
in programming language, if you will talk about the object, this is also a small unit. Okay, and this is also a small unit. So odd is nothing, but this is the smallest unit in the uh, DevOps, or you can say like in Kubernetes. Okay, this is the smallest unit. Okay, so we will explore more about the code. Okay, so okay, so now coming today I will brief about Kubernetes means architecture. Okay, little bit only I will explain, and in the next means in the next class I will means explain deeply. Okay, today I will aware you guys from the word. Okay, like see actually Kubernetes architecture is a little means like so many things are available. So maybe if one time if you will see, maybe you will forget some term and like word. Okay, so whatever I will take, maybe you will forget it. Okay, so today and in the next class we will explore more. Okay, so today I will show you a brief on uh, architecture. Okay, so I will draw here one Kubernetes architecture. Okay, so Kubernetes TS. Okay, architecture. Okay, yes. Now see, I'm trying to draw one diagram. Okay, so that you guys maybe little bit maybe you guys maybe understand. Okay, okay. So see, in Docker there is one master and two worker node. Okay, so here also first we will take one master. Okay, so like 1 minute, I will use a small. Okay, Kubernetes architecture. See here. Okay, see this one is master. Okay, and here master is also called as control plane. Control plane. Okay, and here is like one worker node one. Suppose this is worker node one and this is your worker node two. Okay, so now first we will see what are the things available in the worker node. Okay, so here if you will see, just now I talk about the pod. Okay, just now I talk about the pod. Okay, so here suppose on worker node one pod is available. Okay, one pod is available. One pod is available. So just now I shown you inside the pod only our container will be available. Okay, maybe container one or maybe container two. Inside pod maybe container one or maybe container two may be available. Okay, can be available. Okay, so and inside the worker node maybe number of pod may be available. Okay, pod.
So inside one pod, multiple container we can put.
Yes, multiple container you can keep, and inside the worker node you can keep multiple pod also. Okay.
Okay.
Similarly, here whatever the work will here like worker node one, same will be here. Okay. Not like see means whatever the pod will be available, not same pod means pod will be available. Like it see pod is what pod. See if I will draw here, so this is the replica of this one, right? This is the clone of this one. Okay, so like um, like one application we have, there we have six pod. Okay, six pod is required. Okay, suppose two pod is available on worker node 1 and four pod is available on the worker node 2. One pod, two pod, three, four pod. Okay, four pod inside the worker node 2. These are the pod. Okay, so what happened here? There is one application that one having four pod. So on worker node, two pod is assigned, and on worker node 2, four pod is assigned. Okay, inside the pod, container will be available. So container will be same. Okay. Now pod is available. Okay. So on the worker node, one more things will be available. Okay. One is uh, kube proxy. Kube kube proxy. Okay. And kube proxy. Okay, and kubelet is available. Cube spelling I am forgetting. Kubelet, I think this spelling is correct. Okay, yeah, so here two things will be available. Okay, I am coming to the here. Okay, I will draw worker node here. Okay, little bit big. Okay, suppose this is your first understand the worker node. Okay, so I drew here pod, two pod. Okay, inside this one container. This is pod and this is container, means container 1. Container will be same. Okay, okay, and here one kube proxy will available. Kube proxy is very important. Okay, whenever your interview will be scheduled or will taken, interview will definitely will ask you kube proxy. What is kube proxy? Okay, and one is kubelet. This architecture is very important, guys. Okay, kubelet, kubelet. See, actually, what is the work of kube proxy, and what is the requirement of kubelet here? Okay, see, before understanding these things, okay, I will come to okay, right now you can understand it as a, this one is maintaining the IP of container. When okay, sorry, means pod. Whenever pod is created, okay, so pod having one IP is assigned. Okay, one IP is assigned like anything 192 anything. Okay, each pod having different IP will assign. Okay, so whose work is to assign the IP? Q proxy will assign the IP to the pod. Okay, Q proxy will assign one IP to the pod. Okay, now here kubelet is available. Okay, what is the work of kubelet? Now kubelet. See what kubelet will do. This
will
kubelet. Yes, yes, Nandita.
Yes, it will check that container are running or not running.
Yeah, this will check. Okay, this will check this pod. Okay, this pod is running or not. Okay, this pod is running or not. Okay, before that one, this one a container engine is available. Okay, one container engine is available. Okay, this this container will stop and restart the pod. Okay, this container engine will stop and restart the pod. Okay, so here we have talked about four things. One is pod, one is proxy, and one is kubelet. uh, Kubelet what will do? What kubelet will do? Kubelet will check. See what kubelet work. Kubelet always will like timer. Okay, every 30 second. Okay, every 30 second this will check our pod is up or not. Okay, this kubelet will check every 30 second. Okay, every 30 second this will check pod is available, means pod is up or not. Okay, that is the main work of kubelet. Okay, and container means sometimes you want to restart the pod also, sometimes you want to stop the pod also. Okay, that is the work of this one container engine. I think kube proxy, kubelet, container engine, and pod little bit clear. I think, guys. Uh, Cube proxy,
Yes.
kubelet, container engine. I think a little bit clear. Okay, right now I'm not going deep. Okay,
So
right
is
now.
a container engine and a C advisor both are same or different?
Sorry, Nandita.
Container engine or C advisor?
C advisor. C advisor will be same. I think. I need to check this one. C advisor. C advisor. Maybe someone have given container name engine as a C advisor because this is the advice. I will check it. Okay, I haven't seen this one C advisor till now. I haven't seen this one C advisor. Okay, I will check and let you know. Okay.
Okay.
Mhm. So right now we talk about three words. These three word means four word. I think little bit clear about these things. Okay. Now, now again we will come to the top. Okay. Now little bit we will come to the master side. Okay. Now we will come master side. See here. Here also so many things are available. Okay, like apple application application controller controller manager. Okay, I will draw here. Okay, and then means in the next class I will mix up those two things. Okay, I will draw somewhere one peak. Okay, and I will show you. Okay, so see, suppose this is your master. This is your master. Okay, master, or you can say like control plane. Control control plane. Okay. So see here one application controller. Sorry, manager controller manager. Okay, and one more is there, cube scheduler. Cube scheduler. Okay, cube scheduler. Okay, and one is etcd. Okay, and one is API server server API server. Okay, here mainly uh, four. Okay, one is application control manager, one is etcd, and cube scheduler and API server. Okay, here we have four things. Okay, so now before this one, like see in Docker, what you see in Docker, we have executed like one command. Okay, here we have created one cluster, Docker node ls. Okay, so here in Kubernetes, 1 minute guys, रुको ना 10 मिनट और रुक लेगा हम चलो. हाँ yeah guys. Yes. Here we have four things. Okay, one is application controller manager, and one is etcd, and one is cube scheduler, and one is API server. Okay, before this one, there is one CLI. Okay, there is one CLI. CLI means what? CLI means command line interface. Command line interface. Like see, we have educated like Docker node ls. Docker node ls. Okay. So similarly, this is CLI, right? This one is hitting to someone. This one is giving instructions to someone. Then after this command will work. Okay. Similar kind. Here one CLI is available. Okay. And when you will install means when you will create cluster. Okay. When you will create cluster, either minikube, or kubeadm. Okay, kubeadm. This will give you one command. Okay, kubectl. Okay, kubectl. Someone is pronouncing like cube cattle. Someone is telling like kubectl, and I don't know means more words are there. Cube. Yeah, two things I know. Cube. Someone is telling like cube cereal. Someone will tell like cube cattle. Okay, so when you will create a cluster, okay, this word will come. Okay, and like see if you will type one command, like if you want to see the cluster, like so here you will write kubectl get nodes. Okay, this will give you the cluster name like master worker node. Okay, so now this instruction, suppose I given this instruction. Okay, I have given this instruction on the server on master node. Okay, on master node I have executed this command. So this command will directly, where will go? Directly will go to the API server. Okay, where will go? API server. Okay. Now, what is the now this this command directly where it goes? API server. Okay. Now API server will send this one to etcd. Etcd is the uh, database. Okay. No SQL database means whatever is available on your cluster. Okay, those all information this etcd will store. Okay, this etcd will store. Okay, so as the instructions came through the command line interface, okay, this will check. Okay, this will check. Okay, these things is available or not. Okay, now thereafter again this will tell. Okay, again will come to the API. Now this will send to the application controller manager. Okay, this will come to the application controller manager. Okay, now suppose we have given um, like we want to create a pod. Okay, so that is our requirement, means that is our we can say like desire. Okay, so now application controller will check with scheduler. Okay, this application controller manager will check with cube scheduler. Okay, cube scheduler will check. Okay, and whatever the information like whatever means how much memory, how much RAM is available on worker node. Okay, on worker node, those all information is available. Okay, with this information this will go to this one. Okay, and and now this will check with cube scheduler. Okay, one more things here etcd. Okay, and etcd will talk to this one also. Okay, scheduler. Okay, see first what etcd will do, etcd will check or keep the information of whatever the resources is available on the worker node. Suppose you have 5 worker. Okay, suppose you have 5 worker node. Okay, so now this will check, means where resource is available. Okay, where is the most resource is available. Okay, according to that this will give information to this one. Okay, and this will tell to this one. Okay, this
So
will
here etcd act like a database.
this will act as a database. Okay, and this will act as a front-end component. Front-end component, why? Because this is the uh, component which is giving those all kind of information to the application manager and cube scheduler. Means this will talk to each one. Okay, this will talk to each one, and this will talk to worker node. Okay, this API server. Okay, that's why we are calling as front end component. Okay, front component also we are telling to this API server, because whatever you are executing the command on CLI, that will directly come to the API server, and API server will share the information and check the information with the etcd, and this will check with application controller manager. This will check with cube scheduler also. Okay, that's why we are calling this one front component also. Okay, okay, And so
A
whatever
little
this
confused about the workflow. Like as soon as the request came, it will go to API server.
API server,
After that, it will go and check with the etc.
etcd, and
And
this,
when the response came back to API, once again it will go to application controller.
yeah,
Then
and
when
this will set this one having one job to create code. Okay, this will decide this will decide where pod will create. Okay, and this will tell how pod will create. Okay, this will schedule, this will tell to API server where on which worker node this pod will go. Okay, this will give the notification, or you can say where the pod will create. Okay, where the
so
pod will create.
application manager will give response to kube scheduler that when the pod will create and where.
Yes, yes, correct.
And then the kube scheduler will again response back to API server.
Yeah,
That here he will provide the details that where and you have to create the pod.
yes. And with all the information, this will goes to the API server, and API server then those all information come with this one. Okay, that which on which worker node this will go. Okay, because we have here multiple worker node. Okay, so those
So
all
API
this is,
server will decide that in which worker node that pod will create.
no, API server will not
So like
decide.
their cube scheduler will already
Ha,
respond back that you have to create that
yes,
pod.
yes, this will schedule. Okay, this will schedule that where our road should goes, because see those all information came with this will check with application manager. Okay, this application manager will talk with cube scheduler where those all things are, those all discussion will be happen here. Okay, like this is a meeting. Okay, this is a meeting hall.
Okay,
Okay,
so with all the information that API server will simply go and just create the pod in the worker node.
yes, yes. uh, I think a little bit, I think clear to all, I think.
Yes, clear.
Okay. So today's I have some work, like means I have to go somewhere. Okay, so today I'm dropping the class. Okay, so in the next class I will means explain this one means in more details. Okay, I will explain one by one. Okay, like master and what are the component available in the worker. Okay, these all things we will see. Okay, one by one. Okay,
Okay.
so this is the means brief architecture, means short architecture of this one Kubernetes. Okay, so I think a little bit idea you guys maybe got it. Okay, so in the next class I will explain these things again, and we will deep dive. Okay.
So
Okay, guys. So today's that much only. So thank you.